Hi, my name is Jim Berthold, and I'm the Vice President of Customer Support for OLI Systems. Today, we're going to go through a very brief tutorial about how to enter Bromley-Zemaitis and Pitzer coefficients into an OLI databook and then have those be used in the OLI software. The Bromley-Zemaitis equation is an activity model and was developed starting way back in 1971. Joe Zemaitis is one of the co-founding members of OLI Systems, and he extended Leon Bromley's equation for higher temperatures and higher concentrations. We no longer use this model actively in the OLI software. We prefer to use our mixed solvent equation of state. However, we do have about 8,000 components in the database in the older BZ formulation, also known as the aqueous framework. So a user asked us to help them enter these equations. So we have a paper published by somebody who is not OLI Systems, and this was Liu et al., published in the Journal of Chemical Engineering Data. I will show you the reference in just a second. But this is copyrighted information, so we're not going to spend a lot of time in the paper showing you what it is. However, I do want to come down very briefly to actually show you the reference here at the bottom of the article. All right, what I've done here is I've scrolled down the article to Table 7 in this reference, where the author has regressed Bromley-Zemaitis interaction parameters as well as the Pitzer two-parameter model parameters here. And we're going to enter both in this tutorial. How the authors came up with this information is detailed quite explicitly in this paper. And for those of you who want to understand how the user actually got to this data, I recommend you go back and look at the paper. But that's not our point here. We're going to go ahead and enter this. This is for ammonium ion and the vanadate ion, as well as ammonium ion and the vanadate acid molecular component. We're only going to be looking at these two interactions here. There are more in the paper. You can add them if you want. The thing that we're not going to show you here is how to enter data for the individual ions in the paper, the ammonium ion and the H2VO4 ion and the HVO4 ion. These currently exist in the OLI software, so we can just use them directly and add these parameters. I will note, just for completeness, that this interaction here, the NH4 H2VO4 ion interaction, currently exists in the OLI software, but we're going to add it anyway because it's actually different from what we have in our model. This interaction of the ammonium ion and the H3VO4 neutral species is not currently in the OLI software, so we're going to add that fresh. So we're going to go ahead and get started looking at this. We'll come back to this paper later because we'll actually need to know how these actual values. Okay, we've started the OLI databook program. This is the current release of version 11.5.1. Nothing's going on here, so we're just going to go ahead and create our first database. We do that by clicking on the New button up here. That creates a new document. All Microsoft Word products and other products, they all have this functionality. You can also click the icon here, which will also give you similar information. There are two databanks which are installed by default. This is the MSE database, which is the default for the 11.5 software, and the older aqueous database. But we're going to go ahead and select New, and it's going to ask us which thermodynamic framework. We have three choices here, the MSE and our MSE SRK frameworks. Since Bromley-Zemaitis is only in the aqueous framework, that's what we're going to select here. We are going to give it a name of the database, and we're just going to call it NH4VO3. And we can give it the full database, the ammonium vanadate database. We can get even more descriptive here. We're not going to. You can give it a version. Since this database is actually 11.5.1, we'll use that. You can also password protect it. We're not going to do that at this time. So we're going to go ahead and click Save, and that actually does some thrashing. It's going to ask us to save the database. All OLI databanks that are used by the user are stored in your documents. So that's your username under here. If I expand this, you'll see that. Sorry, that's wrong place. Let's go back to my OLI cases, databanks. What I wanted to do is show you that that's got my full name in there and so forth. It must go in this folder. So it can't go anywhere else. It must go in this folder. So I'm just going to go ahead and click Save. If there's a database with a similar name, you will be warned. So we'll go ahead and click it. And we are ready to go. It created the section. We're then going to go down and enter our interaction parameters. That's what this is called. This is an IN interaction parameter, and that's done under the interactions chapter. And we are going to start by adding our first species. You can search for it. You'll be here all day, or you can just type in. Now, these are always done in OLI tag names. They're much harder to use, but you can figure it out. So we know that ammonium is NH4. NH4. As we go here, it starts sorting. What's different here is that we're going to add the words ION to it. Okay. The last one is H2VO4 ion. So we'll start with H2VO4. And you see it comes up real quick. Okay. And now we're ready to add it. We'll click Add. Okay. And now we have the species. However, there's no data here. So now we need to go into the actual species up here. We're going to go over here and right click on this and select interaction type. And we have a variety of them here. The first one we're going to do is enter Bromley. This is actually Bromley-Zemaitis, but we just call it Bromley. And it gives us our parameters. Now we need to go back to our paper and actually start adding them. So we see we have these parameters here. It's going to be hard for me to show them all simultaneously here. And I'll try to zoom it in a little bit. Oh, that was the wrong direction. So we'll go to fit to width. And perhaps if I go ahead, there we go. Okay. So we just have these parameters, and you can see they've listed B1, B2, B3, here B1, B2, B3. So we'll go ahead and enter these things in one at a time. For example, I know this one here. You can't reuse. Sometimes in Word, in a PDF such as this, you can actually cut and paste. And that worked. So I'm going to do that now for all the parameters in this particular field. Okay, you can see I've entered the parameters here, and they correspond here. The program, even though I've entered in a value like the C2 here as a 10 to the minus third variable, it actually puts it into a more common format. At this point, I'm ready. I can go ahead and click Save, which saves the database at this time. I now need to add that other parameter. Going back to the document here, I now know that that is an ammonia H3VO3 species. This is a Pitzer interaction, so I'm going to do exactly the same thing. I'm going to add a new parameter. I go back to the interactions line, and I'm going to add the species. This one is a neutral. This one, we'll go back and check. I confused myself. It's NH4 ion and the neutral H3VO4 species. So once again, I will be on NH4 ion, press enter. And this one will be H3V. There's only one, so we'll go ahead and pick that. And click Add. And you see it added it over here. Once again, I'm going to add the interaction type. This time it's Pitzer. Now we're not using the standard Pitzer formulation, which is a 3-parameter term. We are only using a 2-parameter term. You can see we have the B01, 2, 3, B11, B12, B13. We do this exactly the same way as we did with the Bromley parameters. We're going to go ahead and just enter them, copy and paste, and or by manually typing in. So we'll go ahead and do that now. Okay, I've done that now, and you see that the parameters have lined up here. There's a little star here that lets you know that this information has been changed. I no longer need to see this document, so I'll go ahead and close it, and I'll save it once again. I'm now ready to go and actually use this new database in the software. I'm going to use OLI Stream Analyzer for that through the OLI Studio product. So I'm going to go ahead and minimize this, and I will start OLI Studio. And here is the program. We'll go ahead and stop it. As you can see, as I create a new stream, it actually defaults to MSC. That won't work here, so I need to go to AQ because that's the way I created the database. I will now go into Chemistry, Model Options, and I will look for the database I just created. And there it is. And I will go ahead and select it. And I can now use it. I can now type in my components and H3O4, and we can run our calculation. And this is now using the new database. You can see it's listed right here. So that's how to import data from a literature source. You can do that for all the things you find in the literature. Please remember, I missed a lot of things here on purpose. I did not talk about the Gibbs for energy of any of the components that the author used versus what OLI has. I didn't talk about any of the Helgason equation of state parameters, which the author has versus what OLI has. They all need to be consistent. The standard state model must match the activity model. But that's a lesson for a different day. I hopefully have you find this interesting and of some use. So please like and review. And if you have any questions, please email us or use our support portal at support.olisystems.com. Thank you.